Let's get started with the complex potential. What is this? This is basically the plane that is irrotational plane flow of incompressible and uniform density fluid for which the velocity potential function and stream function exist. So basically phi and psi, these two should exist. So let's see that what were the formulas for them. Do you remember the formula for psi? We know that u is equal to negative d psi dx, v equal to negative d phi dy, right? And u equal to negative d psi dy. In this case, this is y, and v is equal to d psi dx. Okay, so this is actually psi. This is psi, and this is Hi, right? This you need to. So how you can remember? Say this is stream function. So this is S. So this is basically stream function. Stream function. By this you can easily keep this in your mind, right? So I hope that you are clear with the formulas. Let me remind you again. So this is basically phi. This is the potential function. So this says that the the partial differentiation, the partial derivative of this potential function with respect to x will, the negative or partial derivative with respect to x will give you the velocity component along that direction. Like if you are doing the derivative with respect to x, you will get the velocity component along the x-axis, and we know that along the x-axis the velocity component is u, and along the y-axis the velocity component is v. So this was basically our potential function. Get started with the things that we need to know now. So see, what is the complex potential in this case? So we are basically interested at the complex potential, right? So complex potential is basically nothing but this w. Okay, this w is the complex potential because this w is equal to phi plus I psi. This is nothing but what, let me write it again. W, this is the complex potential. This is equal to phi plus I psi. Okay, and this phi is of course x comma y. It's having x comma y. So this is the you can say the basic idea behind that. Now see, w is equal to psi I x plus I y plus I psi x comma y, right? This is phi and this is psi. This is real function and this is of course imaginary function. Suppose that all four first order potential derivatives of the phi and psi with respect to x, y exist and are continuous throughout the plane of the flow. This is what sir is trying to tell is, see, we have already seen the values of u, v, right? See, from here you can say that this u is equal to d phi dx, this u is equal to minus d psi dy. So as this u and this u, we can say that these are equal. So what we can write from these two equations? From this equation 1 and from this equation 2, we can say, if we compare the left hand sides, we can say that d phi dx equal to d psi dy. This is what sir has done here. This u is equal to nothing but d phi dx equal to negative d psi dy. Isn't it? Is it clear now? And in the same way, we are saying that this u and this v and this v, as they are equal, let me write it. See, this v and this v. So we can compare this part and this part. So we can say that d phi dy equal to d psi dx, and here is a negative. So negative d phi dy equal to negative equal to d psi dx. With this, with equation, if we compare equation number 3 and equation number 4, by comparing these two equations, as the left hand side is equal, as in both of the case we are having v, which is the velocity component along the y-axis, right? So I hope that it is very easy for you to understand now. Let's now see that what we can write from here, that v is equal to what? Negative d phi dy equal to d psi dx. Here, very important, notice this, that this phi and psi satisfy the CR equation. CR equation means the Cauchy-Riemann equation. Okay, so from this we can say that dv dx, negative dv dx equal to negative du dy, and dv dy equal to negative du dx. So actually they are satisfying it already. That is why we can say that actually they are equal. Like equation 1 and equation 2, we can compare like that. So that's it, and w must be analytic function. That must be an analytic function, and we know that z equal to x plus iy. This is basically an expression of the complex numbers, right? Where x is the real part and this part r plus iy, it is the imaginary part, where I is equal to negative root over 1, right? This is the complex number. Well, and we can say that w is a function f of z, so that is equal to phi plus I psi. So the function w equal to f of z is called the complex potential function. So I hope that this is pretty much clear for you to understand now, right? Okay, so what we did so far, we have said that w, let me write it down, w is equal to phi plus I psi, where this phi is a potential function, and this psi was basically nothing but stream function, right? Stream function, and I have already told you that this psi, how do you pronounce it? Psi, S-H-I, psi. So from this s and this s, you can remember this psi is basically stream function, and this phi, is basically our potential function, right? Okay, and then what were the equations we wrote? We wrote that the equations here, u equal to, in case of this, these are the equations in case of potential function, and these are the equations in case of the stream function. Okay, okay, so we are done with that. So this w is a function of z, and this is called the complex potential function. Okay, what is complex velocity? We already have w equal to phi plus I psi and z equal to x plus iy. So from here, if we differentiate it partially with respect to x, what we are getting? So let's differentiate this w with respect to x. We are getting d phi dx plus I d psi dx, right? All right. So now, what is this? D phi dx. We've written d phi dx, and in place of this d psi dx, okay, in place of this d psi dx, what we can write? In place of this d psi dx, what we can write is, we can write negative d phi dy, negative d phi dy. How? Let's take a look at this equation. See, from this equation, we can write what we had. We had here d phi dx, right? We had d phi dx. So, sorry, d psi dx. We had here d psi dx, and here we also have d psi dx. See, here we have d psi dx. So, in place of this d psi dx, what we can write? We can write this negative d phi dy. Negative d phi dy. Cannot we write this? And we name this equation star, and we are basically using that star equation. In place of d psi dx, see, in place of this d psi dx, we are writing d phi dy. Why? Because we are trying to consider this phi only. In both of the cases, we are only trying to bring it in a common term, that is phi, potential function. So d phi dx, and what is d psi dx? We have already seen that d psi dx can also be written as negative d phi dy, in order to bring this phi common, right? We have written this, so we can very easily write this thing as well here, right? So okay, so now let's move forward and see what we can do from here. Okay, but and here let's take a look. This d phi dx, is basically nothing but negative u, right? And this d phi dy is nothing but a negative v, right? So that because it's a negative v, so that's why this minus and this minus is giving you this plus. Okay, I hope that all of these things are very easy to understand. Actually, if you are just thinking these equations in your mind, you can very easily deal with these things. And then see, but what we have got here is, this is a partial differentiation, but in order to bring a a complete differentiation, we are writing it like this. See, from here, dw dz, dx. Okay, so these two are definitely going to be cancelled out, so you can like write it. This is a property of differentiation. This is a property of differentiation. From there we can write this. And now what we have got here is, so dw dz equal to negative u plus iv. From here we have got this. From here, sorry, so from here we already got this, right? We already got that what dw dz equal to negative u plus iv. So we have just put that value here, and if you just keep this negative sign, this negative sign here, if you bring that, then what you will get? We will get negative dw dz equal to u minus iv. This is very important thing. See, u minus iv. This u minus iv is nothing but the complex velocity. This u minus iv is nothing but the complex velocity. You will see that. See, this u minus iv is known as the complex velocity. Here you can see u minus iv is known as the complex velocity. Okay. And we are also doing some other things here, that negative dw dz equal to, in place of u, what you can write is, see, this is u, this is v, this is q, right? This is see, this is q. So what you can do, you can write in here that if you do this, you can take the component of q on the x-axis, along the x-axis, that will be q cos theta, and along the v-axis, or along the, you can say, y-axis, the velocity component along the y-axis, that is v, that will be q sine theta, right? This is basic geometry. Or you can say, we also have studied in the vector chapter. So from here you can get these things like q cos theta minus iq sine v. You have just replaced the value of u and v. Okay, so value of u is q cos theta and value of v is q sine theta. You have just put that value, and this is basically Euler's formula. Cos theta minus I sine theta equal to, cos theta minus I sine theta is equal to e to the power minus I theta. This is a very beautiful formulation of mathematics. So from here you can see this is Euler's formula that is applied here, and you can get q e to the power minus I theta. Here, this u minus iv that I have already told you, this is actually our complex velocity. This u minus iv is our complex velocity. So we have got this equation by using actually complex potential, which is w. We have used that w, and we have already ended up getting complex velocity equation. So what you need to keep in your mind here, and here are some points. Stagnation point. At this stagnation point, this dw dz is equal to 0, and the speed is basically nothing but dw dz. And if you take the modulus of this dw dz, what is mod dw dz here? See, this is dw dz, right? That is that is basically negative dw dz is equal to what? Minus u minus iv. So from here, if you just try to take the value, you can get this value very easily, and this is root over u square plus v square, and this is basically our speed.